So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So this is practice question number 6 of the linked list series. The whole linked list series for learning the concept has already been uploaded on the YouTube, so please follow that. The link is present in the description, right? So we are going to see the question linked list cycle 2. Now I would like you to please see the prerequisite for this video, which is linked list cycle, which has been uploaded as video number 9 in the playlist, in the given playlist, right? So please do see that before watching this video. Otherwise I will explain the same approach here also, right? So what does the problem say? The problem says that you have been given a linked list. As you can see, this is a given linked list to you. This is my head, of course, and now you are able to see that this linked list has a cycle, right? This is a clearly visible cycle here. This is a clearly visible cycle here. Now you have to tell me the starting node of the cycle. You have to tell me the starting node of the cycle. Starting node of the cycle. What is the starting node? Can you say this is a part of the cycle? No, no, no. This 4 is a part of the cycle, and you can see this 4 is the earliest to reach from the head. This 4 is earliest to reach from the head. So this is my answer because this is my starting node of the cycle right? You have to return me the 4 in this case. You have to return me 4 in this case. The observation, the doubt is how will I reach this 4 and how will I say determinately that this 4 is my answer which I am looking at. Okay, so let us see the brute force approach first. The brute force approach. Brute force approach is simple. Now you know that each node should appear once if there is not a cycle. Each node should appear once if cycle is not present. If cycle is not present, right? This is my first point. Each node should appear once if cycle is not present. That is, that if the cycle is not present, 1 will go to 2, will go to 3, will go to 4, will go to 5, and now because the cycle is not present, 5 will be touching the null. As soon as I come towards the null pointer in my traversal, that means the cycle is not present. Null should not be a part of the linked list. Null should not be a part of the linked list. This is my point number 1. So my approach says, should I keep a set? Should I keep a set? You can use a map too. I'm using a set. Keep a set of type list node start. I will store the whole list node into my set data structure. Name it as st. Okay. Now traverse. That how do we traverse a linked list? Temp equals to head. And now traverse, that is while temp. While temp. What will you do? First push the node. Your temp is currently here. Push the node into the set. Push the node into the set. So st dot insert temp. You push the node into the set, right? But before that, check. What do we check? If the node is already present. So before this operation, check. So if st dot find the same temp we are talking about is not equals to st dot end, is not equals to st dot end, I will say tell you what to do. Otherwise, st dot insert temp. So what is actually happening? Your temp is here. Your temp is here. Suppose this is your set. Your temp is at 1. It will contain the 1 node. Temp moves here. It will contain 2 node, 3 node, 4, and up till 11. 4 up till 11. Right? All these nodes 5, 6, 7, 8, 9, 10, 11 will be pasted in the set data structure. When after 11, I will move to 4 again. I will move to 4 again, and for 4, you can able to see that this condition will come true. This condition will come true. That is, I am able to find the same node already present in my set. Now, can I say that this node is my starting node? The node I encounter first, which is already present in the set, is my answer. Node I encounter first, which is already present, in set, is my answer. So as soon as you see a node which is already present in the set, that is your answer. So return temp, right? And after inserting, you have to move to temp equals to temp next. That is like basic thing. So you must have been knowing that temp equals to temp next. This is inside the loop, right? Now, if this loop breaks and this condition is never called, if this loop breaks and this condition is never called. That means temp has become null, then only the loop can break. So in that case, return null. Return null. That is, the linked list does not contain a cycle. The linked list does not contain a cycle. Okay. Now this is my brute force approach. Why am I mentioning this brute force approach? Of course, this is using O of n time complexity, or I can say O of n log n, because I'm also inserting into the set. But it is using O of n space also. This is my point of grief, that I don't want to use O of n space. Can I do it in better time complexity? Of course I can do. You are here to see the better time complexity only. Okay, so let me draw the linked list again. Let's discuss the optimal approach, right? Optimal approach. Optimal approach is same. The slow fast pointer. Slow fast pointer, which we have already discussed in the playlist. So please follow that. Slow fast pointer says that if you keep two nodes at the head, that is, slow is at the head, fast is at the head, right? Move the slow pointer one time. That is, in each jump, slow pointer will move one jump, and the fast pointer will move two jumps, right? That is, after one iteration, slow will come here, fast will come here, right? So I will rub these slow and this fast. After that, again, slow will come here, and fast will go from 4 to 5. Fast will reach here. That is, this is removed. After that, slow will come at 4 and fast will go at 6, 7, right? Okay. After that, slow will come at 5, fast will go at 9, right? So rub the initial configurations, right? And after that, S will come at 6, F will go at, from 9 it will go towards 11, right? So remove the initial configuration. It was here, here, and here, right? S will go to 7, but F will go to 11, 4, and then again 5. F is again at 5, right? S is removed and F is removed. After that, S will go at 8 and F will go at 7. Again, remove the initial configuration. After that, S will go towards 9 and F will go towards 9. And you can see that S and F coincide. And as soon as they coincide, that means cycle is present. As soon as S and F coincide, cycle is present. Cycle is present. But my main concern is that I wanted to find this node. I wanted to find this node. But 9 is not the starting node. 9 is not the starting node, right? So I have to think of reaching this node from 9. I have to think of reaching this node from 9. I know about this, that as soon as S and F coincide, cycle is present. And as soon as I'm sure the cycle is present, there has to be a starting point. Now, if I try to do this mathematically, let's suppose this length is L1, right? And this is meeting at 9. This length, the circular length, is L2, and the whole length of the circle is K. So suppose this is the initial configuration. L1 is this length from the head to the starting point, and L2 is the length in this cycle only, and K is the total length of the cycle. Now, what is actually happening is, as you can see, that F completed a whole circle before it met S, right? F completed a whole circle. F completed a whole circle before it met S. Before it met S. Correct? Now, in this scenario, F completed a whole circle, but it might be possible that F completes many circles. It might be possible that F completes many circles. So suppose distance traveled by F, distance traveled by S is actually equals to L1 plus L2, right? But the distance traveled by F is equals to L1 plus Nk plus L1 plus L2 plus Nk. Something like that, L1 plus L2 plus Nk, because you can see that after traversing k times, it again traveled L2, so Nk into L2, right? Okay, now we know that fast was actually moving at a twice speed, that is, distance of F should be equals to 2 into distance of S, because of the speed only, nothing else. That means I'm saying that L1 plus L2 plus Nk is equals to 2 into L1 plus L2, which is reduced to L1 plus L2 plus Nk equals to 2L1 plus 2L2, and if I subtract them by taking it here, Nk equals to L1 plus L2. Nk equals to L1 plus L2, and I can say that L1 equals to Nk minus L2. L1 equals to Nk minus L2. Okay. So, is it the distance or is it a displacement? Is it actually possible to get L1 as Nk minus L2? Is it actually possible to get L1 as Nk minus L2? No. because the distance can be, like you can see that it can have traversed 5 circles and the circle length is 1 2 3 4 5 6 7 8. So 5 into 8 40 minus 1 2 3 4 5 minus 5 35. It is not equals to 1 2 3 4. It is not equals to 4. It is not equals to 4. But I am saying something like this, that this length this length is actually equals to L1, that is 4 11 10 9 is actually equals to 1 2 3 4. How am I able to say that? How am I able to say that? From this operation only. Nk minus L2. Nk minus L2. That is, from the complete n circles, subtract this L2 length and the remaining length will be L1. That is what is saying. From the complete circle's length, that is Nk minus L2, you will get L1. This is my L1. This is my L1. That means from the starting point, let me write it down. From the starting point, S and L, S and head are at are at same distance, are at same distance. So my algorithm breaks down to this. If I keep a temp pointer here and if my S is already here, move S one pointer S, move temp one pointer temp here, S here, temp here, S here, temp here. As soon as they coincide, that is my starting point. That is my starting point. That is my starting point. So what is actually happening is I'm doing something like this. My first part is to get the confirmation whether cycle is present or not. So I will say fast equals to head. Similarly, slow equals to head. Now you will say that while fast and fast next, both of them are present. So what will you do? You will say fast equals to fast next of next, and slow equals to slow next. Slow equals to slow next. Why have I used fast and fast next? To avoid the segmentation fault. Avoid segmentation fault, because if next is not present, then I cannot assign the fast of next, right? Okay, if fast equals to slow, you can say that, let's say bool flag equals to false. For cycle, you can say flag equals to true, flag equals to true, and now break, and now break. Now you can say if my flag equals to false, if my flag equals to false, that means the cycle is not present, and the fast and fast next, one of them is null. That means the cycle is not present in the linked list. You can say simply return null. I don't find a list node, right? Otherwise, what you can do? Otherwise, you can say temp equals to head, and now while temp, right? You can say temp equals to temp next, or you can simply say that before it only you can say if temp equals to s, return temp, return temp, or you can return s because both of them are pointing to the same node. Otherwise, move them one step each. Temp equals to temp of next, and s equals to s of next. Why? Because we discussed that the length of the distance of s from the starting point and distance of head from the starting point is actually same, right? Return temp, and that's all. That's all. You can just return null to avoid the say runtime error, right? Return null, etc. Okay. Now I hope this is clear to you. Any doubts? I'm open to answer you in the comment section. You can DM me on my social media handles as well. Link of all the things are present in the description. So please make sure to check the description out. And if you have understood the algorithm, do not forget to like and subscribe. Okay. And now let us move to the code for it. So here is the coding section, guys. So before starting with the code, I would like to request you to please subscribe to my channel, because it really motivates me when my subscriber list goes up and the views also goes up, right? So let us start coding. Okay, so first I will declare some pointers. List node star slow will be equals to head. Similarly, star fast equals to head, and I'm declaring temp also here. So star temp equals to head, right? Now I will declare a bool flag equals to false currently, while my fast and my fast next, both of them are not null. What will you do? You will say fast equals to fast next of next, because I have to jump fast 2 times, and similarly slow equals to slow next. Now if fast equals to true at any point of time, change the flag to true and break, because you have confirmed that the cycle is present, right? And break. After the while loop, if my flag is currently not true, that means the cycle is not present, and it is a single linked list. So in that case, return null, because there is no cycle, so there is no starting point. Otherwise, if the flag is true, that means I will have to check it while with the temp and s. So if my temp actually becomes equals to s, return temp, right? Otherwise, temp equals to temp next, and s equals to as next, right? Now you can simply return null, because this function list node star actually wants you to return something. It will never return null here, but it is just for the writing of the code, right? You can actually take a list node star answer and store it in the answer, right? Okay, so there has been an error. Okay, it is slow, not s, it is slow. Let us try it now. Okay, it is slow here also, so it will give an error again. Okay, let us try it now. And it is running fine for the sample test cases. Let us try it for the submit as well. Should run fine, I guess. Should not give any error, and it is getting accepted. So thank you for watching. Hope you like the video, and we'll meet soon in the next video. Till then, stay tuned, and please do like and subscribe to the channel. Thank you. Have a nice day.